Okay, hey, let's do a trig review. SOHCAHTOA. This is for right triangle trigonometry, and I'm not sure if we're going to use a lot of this, but remember, sine of an angle theta would be opposite over hypotenuse, okay? Opposite over hypotenuse. Or in the unit circle, where we've got this triangle, as this dot goes around, we form right triangles. This radius is 1, but there's our radius. This is our x component, and this is our y. So opposite would be, opposite of hypotenuse is y over r. Anyway, cosine, the cosine of this angle theta is going to be the adjacent over hypotenuse, or x over r. Tangent, remember, TOA, opposite over adjacent for theta, okay? All right. Remember cosecant. Cosecant does not align with cosine. It's tricky. Cosecant is 1 over sine. So instead of opposite over hypotenuse, it flips. It's h over o, or r over y if we're going off the unit circle. Secant is 1 over cosine. Or instead of adjacent over hypotenuse, it's h over a or r over x. And cotangent is 1 over tangent. Okay? And that'd be, instead of being o over a is a over o. Instead of being y over x is x over y. Excuse me. Okay? So SOHCAHTOA. So notice, when we say sine of theta is going to be opposite over hypotenuse, that's 3 over 5. Remember, we don't know what theta is. We just know that if the sine of that theta, some angle, it's 3 over 5. How do we get that angle? Inverse sine. So if you take the inverse sine of 3 over 5, you get theta. Okay? Make sure you're in degree mode. Okay? When you're on here, we can go doc 7 2 and see we're in degree mode right here. Degree mode. Okay? All right, so we're in degree mode. So I can go trig. Here's my trig. The trig button right underneath the control. Okay? I scroll down to inverse sine to enter. And I'll really blow this up. Okay? All right, control divide. 3 over 5, enter, and that's 36.9 degrees, okay? All right, so remember what we're doing here. If you've got sine of x or sine of theta equals something, to get what theta is, you do inverse sine. I plug in a theta, I get out this, which is 0.6. I do inverse sine of 0.6, I get out my theta, okay? One more thing. Let's take a look at some of this we should really be able to work through fairly quickly. Here's just an example. Okay? Here's cosine inverse of root 3 over 2. So that should give us some angle, right? Some angle cosine of x or cosine of theta equals root 3 over 2. So if I do inverse, or let's do 1/2, I'm sorry. Okay? So if we said cosine of some angle x or theta equals negative 1/2, how do I find that? I go inverse cosine of negative 1/2, and that gets me theta. Okay? I think that should be negative 60 degrees. On. Turn the calculator on. Trig. Inverse cosine. Negative 0.5, which is 1/2, enter, on 120 degrees, okay? All right? So remember cosine, so that's our inverse cosine. I was thinking 60, or negative 60. Anyway, that's going to be 120 degrees, okay? So a little bit about working these problems. We're just getting, when you do inverse sine of something, we're getting the theta, the angle, okay? All right. Now, let's talk about inverse functions here. I'm making some good progress here. Remember what we do with composite functions. If you took the composite of two functions, Okay? Remember we did, uh-oh, my thing's going to slide off here. Okay? Notice, when I'm going to take the composite, this is basically the inverse. What am I putting? This is the inverse function composed of the function. Okay? F inverse circle F. I plug in x into f, and the output f of x is now the input for the inverse. And if they are indeed inverses, you just get back x. Okay? That was one of our tests for those composite functions. If you plug in something, if you plug in x and you get out an output y, and you put in that output y is now your input for the outside function, if you get back x, they're inverses of each other. Okay? So notice here, I'm plugging in the inverse, and the outside function is f, and f is the inverse. And again, I should get back x. Plug in x, I get out a y, I plug in on that y, and they're inverses of each other. So you get back to where you started from. You plug in 1, you get out 2. You plug in 2, you get out 1. Okay? All right. Knowing that, notice how kind of a composite function, cosine of 2 pi over thirds. Okay, here's my theta, radians, 2 pi over thirds, gets me some number, okay? And if I do the inverse cosine of that number, what's the inverse cosine? Takes me back to the radians. So what is the answer? X, 2 pi over 3, okay? So if you look at one of these, where is it? Basically what I'm doing, look at number 5 here. If I plug in sine of pi fourths, I get root 2 over 2. And basically, sine of pi fourths, I plug in pi fourths, I get root 2 over 2. So basically, I'm taking the inverse sine of root 2 over 2, and that takes me back to theta, which is going to be pi fourths. Okay? So anytime you're taking the inverse of a function, it's basically gets you back to x, what your input was. You're getting the inverse undoes what this does, and it takes us back to our input. So this worksheet should be pretty easy. All right? Sine of 5 pi over thirds is a theta. Inverse sine of that theta gets me, sine of this theta gets me some numerical value, and then the inverse sine of that numerical value takes me back to 5 pi over 3. So hopefully everyone understands how we're just undoing what we do with, this undoes what was done here and takes us back to the original input. Okay? Finally, let's look at just using some algebra now. Cosecant of x here, this basically solving simple trigonometric equations. Okay? Find the general solution of each one below. Let's look at this cosecant. Okay? Well, cosecant of x equals negative 2. So what's x, or theta? Well, inverse cosecant of negative 2 will get me theta. Okay, let's check it out. This is what's nice about the Inspire is you couldn't do that. You'd have to know on the TI-84, you'd have to know that cosecant is 1 over sine of theta. Okay, which equals 1 over sine of theta is cosecant. That equals negative 2. Okay, but we have on our trig function here, when I hit trig, right there, trig, I can go do inverse cosecant, enter, and what do we want to put in? Negative 2. So put in negative 2, enter, and that's negative 30 degrees. Okay? Negative 30. All right? And then down here, it's just a little algebra. Okay? I'm going to add root 2 to both sides. Okay? That cancels out. Now I've got 2 sine of x equals root 2. Now let's divide by 2. So now I get sine of x, or theta, sine of x equals root 2 over 2. So what is that going to be? It should be 45 degrees, but we can do what? Inverse sine of root 2 over 2 to get what theta is, or x. Okay? All right? Now my last thing will be trig inverse sine, control divide, there's my, okay, root 2 over 2 inner, 45 degrees, okay? So basically just showing you a little bit of our trig, knowing how to get review. We reviewed our SOHCAHTOA, okay? Sine, this is for right triangles only, SOHCAHTOA. We're basically reviewing that, how to get theta, okay? If you had sine of x equals root 3 over 2, I'll take the inverse sine of root 3 over 2 to get what x actually is, okay? And we learned more about taking the inverse sine of sine or inverse cosine of cosine, and you're just getting theta back, okay? All right, cosine of theta gets me some number, and the inverse cosine of that number gets me back to theta, okay? And then we learned basically how to maybe algebraically solve some things. Here, I subtract 6 and get negative 2, divide by 2, and then sec and so on, and get secant, here would be minus 6, negative 2. 2 secant x, divide by 2, okay? Secant x equals negative 1, all right? Inverse secant of negative 1 will get me what x is, okay? All right, that's it. Enjoy.